Welcome to chapter number 5A, Introduction to Computers. And today's title is Transforming Data into Information. I'm your instructor, Dr. D. So, how computers represent data? Initially, we need to familiarize with number system. So, number system is a manner of counting, and several different number systems exist. For example, decimal number system, binary number system, octal decimal number system, and hexadecimal number system. So first of all, let's see what is decimal number system. As its name says, deci, so deci means 10. So in decimal number system, it contains 10 distinct digits starting from 0 till 9. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Altogether, there are 10 unique distinct digits which collectively make decimal number system. And this number system is used by human beings, and combination of these digits combine together to make larger numbers as we use in our real life. So next, see what is binary number system. It is used by computers to count and manipulate data. In this number system, there are two distinct digits, that is 0 and 1. And 0 and 1 combine to make sequence of numbers. So the question is, how computers represent data? Computers can understand only 0 and 1. So let's see what is 0 and 1. Please keep in mind, if we consider 1, the digit 1, as a state on or a state of yes or a state of true. So this is one state. One state, if it is 1, you may consider it as on, yes or true. The other state is 0. If the number is 0, you may consider it as off, no, or false. It depends upon the situation. So here, for example, there is a electric circuitry. Condition 1, the circuit is off. So we can assign condition 0. While the other condition, the circuit is on, and we can name by condition 1. So let's see what are bits and bytes. So bit basically is abbreviation of binary digit. Binary digit, in short, we say it as 1 bit. Okay, binary digit. So in the previous slide, we saw this is a binary digit. This is another binary digit. So at one place, we can only place either 0 or 1. So that single place is referred as 1 bit, bit, 1 bit. And by combining this 1 bit, if we combine a sequence of 8 unique bits altogether, we refer it as 1 byte. So the story starts here. Now we are very much familiar with what is bit. 1 bit is a single place where we can store one digit, either 0 or 1. Okay, so this is one place, we call it as 1 bit. And in 1 bit, what is stored? 0 is stored. This is another bit, one place to store, and what is stored here? That is 1. So binary numbers are made of bits. 1 bit represents a switch. So as we are observing here, 1 bit, if it is on, we can say this is 1. The bit state is off, we can call it as 0, similarly 1, 1, 0, 0, 1, and 0. And so these are 8 unique bits. Collectively, we refer it as 1 byte. So this is unit of memory. We keep on storing data in computer and we measure in bytes, and 1 byte equals 8 bits. So you have to remember this. So byte represents 1 character. In human in our daily life, we use English characters, that is character set of English language, and 1 character we can store in computer using these 8 bits. These all 8 bits will collectively make a combination of bits to represent 1 character of English. So the next one is text codes. These text codes convert letters into binary. So now we are little familiar with binary bits and bytes. So now we are observing human letters like character set of English language, how we can convert English language into binary language or binary number system, and why we need this. Here's the big question: why we need to convert English language characters or sentences into binary number system? Because this English language character set, English language alphabets are understandable by human beings, and binary number system is understandable by the computing device or computers. So this, you can see that how computers are making transformation and how the machines are making intelligent. So we need some standard code necessary for data transfer. For this particular point, we need some standardization, and there is a standardization that is ASCII, ASCII, that stands for American Standard Code for Information Interchange. There is another standard that is referred as Extended ASCII, and Extended ASCII is used by graphics and some other symbols. There is another standard referred as Unicode or Universal Code. It comprises of all languages on the planet. So here we come. This is ASCII table. We can all refer it as Ascii chart. Here are some values, and these numbers are decimal numbers, right? Here are the characters, and correspondingly these characters, we see that, let's see 65 in this ASCII chart, we see 65. So this 65, this is decimal number, and corresponding to 65 we see capital A is written. So this American Standard Code for Information Interchange table, this ASCII chart shows 65 is equivalent to capital A. Okay, you have to remember this. And even if you don't remember, you just need to understand. Similarly, 48 is 0, and so on. Now this 0 and this 0 are not similar. This is decimal, and these are rather American codes. These are American codes assigned to the character set of English character set. And similarly, another alphabet I would like to show, that is 97. You see that is small a. So you keep on observing and you will get familiar with this ASCII chart. You just need to keep in mind these things. Okay, how computers process data. For processing data, they need CPU, that is referred as central processing unit, and it is primarily the brain of computer. It comprises of 2 parts: control unit and arithmetic logic unit. It is referred as CU, control unit. It controls resources in computer, also instruction set. The ALU, or arithmetic logic unit, is here to perform mathematical operations as well as to control registers. Now let's see what is machine cycle. These are steps of CPU to process data. Instruction cycle. This is CPU gets instruction in instruction cycle. There is execution cycle. CPU performs the instruction in execution cycle. And there are billions, rather trillions of cycles per second data is being processed. Pipelining processes more data. This is another process held in CPU. And multitasking allows multiple instructions. Now let's see how CPU works. Here is the input from human being or computer user. We see that there is combinational logic, and if they need to process certain information is stored in registers. Collectively, this you can see that yellow shaded part is processor, and we have control unit, and here is the main memory. After processing of CPU from combinational logic, output is given to the human being back. So I have borrowed this snap from Intel, and this picture shows the major architecture of CPUs. So Intel Core to Do have the name is written over here, and it was invented in 206, and the specifications are written below here along with the names. This is Core i7 in 2013, and it's Core i7 and Core i7 10th generation. So different generations are also mentioned here. 10th generation Core desktop, we have certain details over here. Processor name, so this is very important whenever you deal with your computers, your computer CPU, how you can judge the name of processor. So this is i9, refers to Core i9, and 10900K. So this 10 specifically refers to the generation. The first, you see that all 10 is written here. So this is 10th generation and following the processor number. Base clock speed is also given, up to how much gigahertz is a base clock speed. Then is turbo boost. So these features are coming in 10th generation, maybe in the recent previous. And then is turbo boost, maximum technology. Then is thermal velocity boost technology. Then is core turbo frequency, core threads, thermal. Here we see memory support. So here is also mentioned how much memory it supports. And if you see that how much graphics it supports is also written over here. There are also dedicated graphic processing units, also referred as GPUs. We will see later on. So what is memory? It stores open programs and data. Simple chips on the motherboard, you can see in this snap. More memory makes more computer faster. What are different types of memory? There is an internal memory and there is external memory. Internal memory, different types of internal memory include RAM, cache, sequential access, virtual RAM or virtual memory, and there is ROM. So these type of memory portions or memory parts lie inside the CPU or inside your processing unit, or may lie on the motherboard. SRAM, DRAM, different types of ROM exist: MROM, PROM, EPROM, and EEPROM. External memory includes magnetic disk, solid state disk, and optical disk. Non-volatile memory. Non-volatile memory holds data when your computer is powered off, also referred as ROM or ROM. Basic input output system is also another kind of non-volatile memory. And post power on cell test. What is flash memory? Commonly used storage device, portable device. Data is stored using physical switches, special form of non-volatile memory, and different commonly used devices, smartphones, cameras. We use flash memory device or mini devices. So this is how internally it looks like. There is a USB controller over here. USB metal head is here, and this is miscellaneous components installed over here. This is quartz resonator and circuit board PCB installed over here. The second time comes is volatile memory, and it requires power to hold data. RAM is a kind of volatile memory. Data in RAM has an address, and CPU reads data using that particular address. CPU can read any address. So volatile memory, you can have access to volatile memory until your power is on. This is a general purpose view of the motherboard. Pardon. So what are the components affecting speed? If you look primarily, we have three factors which affect the processing speed, that is clock speed, number of cores your CPU have, and cache size. What are registers? The number of bits processor can handle, and it includes word size. Larger indicates more powerful computers. Increase by purchasing new CPUs. Virtual RAM. Computer is out of actual RAM. File that emulates RAM is referred as virtual RAM. Computer swaps data into virtual RAM. Least recently used data is moved. So what is internal clock? Quartz crystal. Every tick causes a cycle, and speed is measured in hertz, gigahertz, but we see that latest computers gigahertz are the higher units. This is computer bus. These are basically electronic pathway between the internal components of computer. Expansion bus connects to peripherals, different peripheral devices, and system bus connects CPU and RAM. Bus width is measured in bits. Speed is tied to the clock. And what are external bus standards? One is industry standard architecture as shown in the picture here, also referred as ISA slot. There are local bus, peripheral control interface, AGP or accelerated graphics port, USB. There is another standard, Firewire, IEEE 1394, and different PC cards. So this is PCI slot. It connects modems and sound card, different sound cards. This is AGP, accelerated graphic port. It connects video card to motherboard, extremely fast, found in all modern computers. I would like to add GPUs over here. This particular accelerated graphic port do not include a microprocessor. So all those slots which include a microprocessor, you can refer that as GPU, graphic processing unit. These are different types of USBs, universal serial bus, you commonly use. These are hot swappable plug and play devices. It allows up to 127 devices and different commonly used devices you use. So these are categorized by type A, type B, 3.0, USB mini, micro, USB type C, and micro B. So PC cards, they are also used. They act like a USB. They are hot swappable devices, are the size of credit card. Nowadays they are micro, just like your cellular SIM. They are in the same size like your cellular SIM or mobile SIM. Cache memory, this is very fast memory, holds common or recently used data, speeds up to computer processing. Most computers have several caches. L1 holds recently used data, L2 holds upcoming data, L3 holds possible upcoming data. Thank you very much. We have completed this chapter. So if you have any question, you are welcome to ask. I would like to say, don't panic, and you can stop wherever you like. You don't understand, you can also use certain references. I am going to add some more references if you want to study in detail. So thank you very much.